Now we are going to derive the formula for sine 2a. Okay, for deriving the formula for sine 2a, I am going to apply the old concept, that is, I know already this formula for sine alpha plus beta. Yes, so I hope you remember the formula for sine alpha plus beta. Sine alpha plus beta is nothing but sine alpha cos beta plus cos alpha sine beta. Okay, so this is the formula which we know already. Now, in this case, if both alpha and beta are equal to A, okay, if both alpha and beta are equal to A, then what will happen in this formula? Sine A plus A, which implies what you are going to write here, sine A cos A, and then cos A sine A. So both are same only, right? Sin A cos A and cos A sin A are same. So I can add this, which will give you 2 sin A cos A. So this is the formula for sin 2A. So to derive the formula from sin 2A, I am just making use of this sin alpha plus beta, which is addition identity. Okay. Now, in the same way, I am going to identify the remaining two identities also, that is cos 2a and tan 2a. But before that, here you can note down sin 2a. I got the formula in terms of sin a and cos a. Now I am going to derive sin 2a formula in terms of tan now. Okay, so we'll move to the next one. So sin 2a, I know it is 2 sin a cos a. Now what I'm going to do, I'm just going to divide this by 1. Okay, why? 1 can be written as a well-known identity, which is cos square A plus sin square A, right? I can write like this, 2 sin A cos A by cos square A plus sin square A I can write. Now what I'm going to do, I'm going to divide both numerator and denominator by cos square A. Okay, so in numerator I am going to divide cos square A. So what will happen here? 2 sin A cos A divided by cos square A, and the whole divided by, already you have the denominator, which is cos square A plus sin square A divided by cos square A now. So again I'll repeat. First step, I am just rewriting this one as the identity cos square A plus sin square A, and then both the numerator and denominator I am just dividing it by cos square A. Now you just check what will happen here in the first case. Cos A cos square A you will get cancelled. Okay, so your numerator will become 2 sin A by cos A. Yes. Then you just check the denominators. I can divide cos square A by cos square A, which will give you only 1. And then sin square A by cos square A will remain same in the denominator as well. Okay. Now it's very simple. 2 sin A by cos A can be written as 2 tan A. And then sin square A by cos square A can be written as tan square A. So this is what the formula for sin 2A in terms of tan A. So we have seen two formulas so far for sin 2A. One is 2 sin A cos A and another one is 2 tan A by 1 plus tan square A. In the very similar way, we are going to derive the formula for cos 2A and tan 2A as well. Now we will derive cos 2A formula. Like exactly same like what we have done with the sin 2A, we have used sin alpha plus beta formula, right? In the similar way, we are going to use cos alpha plus beta formula. So first you can write, we know that. So what is the formula for cos alpha plus beta? Cos alpha plus beta, the formula is cos alpha cos beta minus sin alpha sin beta. So you may learn the same identity in terms of A, B also. Okay, so it's not an issue. You can use alpha plus beta as well. Now, in the same way, alpha and beta, I'm just going to consider as A. Okay, now what will happen here? Cos A plus A. So cos A plus A will give you cos A and cos A again, because alpha is also A and beta is also A. So cos alpha, cos beta becomes cos A, cos A. And the second term will be sin A, sin A. Now, in the left hand side, cos A plus A will become cos 2A, and cos A is your cos square A, and sin A is sin square A. So that's all. This is the first identity for cos 2A. So this identity involving in terms of both cos square A and sin square A. Now further, what I am going to do is this cos 2A, the first cos square A term, I am going to write this as 1 minus sin square A, because we know the identity cos square A plus sin square A is equal to 1. So from that, cos square A, I can write it as 1 minus sin square A, and second term remains same. Now check what happens. This 1 will come same, and minus sin square A will become minus 2 sin square A. So this is also one of the identity for cos 2A, which will give you in terms of sin square A. Now you can see in this equation 1, cos square A I have written in terms of 1 minus sin square A. In the similar way, I can write the second term sin square A as 1 minus cos square A, right? So I am going to do that as well. So cos 2A equal to first cos square A, you can keep it as it is. Second sin square A term can be written as 1 minus cos square A. Okay. Now cos square A minus of minus will become plus. So cos square A plus cos square A will give you 2 cos square A, and you have this minus 1 as well. Okay. So for cos 2A, we have written 3 formulas. One will be in terms of both cos square A and sin square A. Second will be in terms of sin square A. Third will be in terms of cos square A. And further, we are going to derive the same cos 2A formula in terms of tan as well. So that's what we are going to see next. Cos 2A is equal to cos square A minus sin square A. I am just using the equation 1 from the previous point. Now I can divide this by just some 1. This applies exactly same like what I have done with the sin 2A to bring the answer in terms of tan, right? I am just applying the same concept here. Now this 1 can be written as cos square A plus sin square A. Now again, both numerator and denominator, you can divide with cos square A separately. Okay, so by cos square A, and the denominator also you can divide it by cos square A. Now listen keenly what will happen in numerator and denominator. Cos square A by cos square A will give you 1. Okay, I am just talking about this area. Cos square A minus cos square A will give you 1. In the same way, second term will be sin square A minus cos square A. Okay, I am just solving only the numerator. Now, in this very similar way, here also cos square A by cos square A will be 1, and plus sin square A by cos square A. Now we know what is sin A by cos A. So that's all your identity for cos 2A in terms of tan. So tan square A. That's it. Okay, it's cos 2A. So cos 2A in terms of tan is 1 minus tan square A by 1 plus tan square A. So you can take this as equation 4. So for cos 2A, we have arrived with 4 different formulas. So first formula we have learned cos square A minus sin square A, and then one will be completely in terms of sin square A, and another one will be completely in terms of tan square A, and the last one is in terms of tan square A. So far we have derived formulas for sin 2a and cos 2a with the help of some identity, that is alpha plus beta identity. Now it's time to derive the formula for last double angle, which is tan 2a. Now let us go to that one. The formula for tan 2a we are going to use just like cos 2a and sin 2a. Here also I am going to apply the identity of alpha plus beta. I hope you know this identity. Tan alpha plus beta is tan alpha plus tan beta by 1 minus tan alpha into tan beta. Just like what I have done with sin 2a and cos 2a, here also I am just going to assume both alpha and beta are equal to a. Now just what will happen on the left side, it will be tan a plus a, and right side it will be tan a plus tan a by 1 minus tan a into tan a. Now what will happen here? Numerator will become 2 tan a and denominator will become tan a into tan a will give you tan square a, and LHS is going to be tan 2a. So that's all with your tan 2a identity. Okay, so you can find common thing between all double angles. I am just taking the help from alpha plus beta formula. So to find sin 2a, I have used sin alpha plus beta. In the same way, cos 2a and tan 2a also, I am just using alpha plus beta. So just by using that identity and considering alpha and beta are equal to a, I am just getting the answer for tan 2a. Now I am just going to a quick recall whatever we have done, whatever we have learned in this video. So just to check out here, so these are the identities we brought in double angle identities. So first we have learned sin 2a in terms of sin a and cos a, and then we have derived sin 2a in terms of tan. So which is 2 tan a by 1 plus tan square a. After finishing, we have also learned how to derive the formulas for cos 2a in 4 different equations, and then I gave you the identities for tan 2a at the end. I hope you have learned how these identities have arrived with the help of alpha plus beta. Okay, so that's all with this video. Thank you so much for watching. If you like this video, if you like my explanation, please hit like and share this video with your friends. Thanks for watching. Take care. Bye bye. Catch you all in the next video.